Alright, we can go to the visual viewer to see the results. From here you can click open file. Let's say we did calculation in MMAW. We have to go to the third folder, which is resu, or short for the result, and we have the FTP file. We can hit open. We're going to select the YX, which is a top view, and from here contour, clicking on contour, we can have our option. We have the temperature node results and temperature node. As you see, it turns green. I will apply the wireframe. Okay, here is the first step, and by clicking on this one it goes to the next step. So here is the weld, and in this time it reaches the maximum temperature, which is 2005 ish, and after that it's going to cool down to the room temperature. Here it is the final 1000 seconds. Here you can see, you can track the time. Here it means maybe 50 seconds or 56 seconds was enough to let this material to be cooled down. So I said that was a very large number to ensure that it cools down. Alright, here we want to check if the root of the weld is melted. So we're going to click on this contour here, and we can adjust the maximum. So I believe the melting point of this metal is 1400, so we can do the maximum on 1400, and we see the maximum of this contour is set as 1400, and it is not completely melted, so it means the root of weld is kinda unaffected, is not melted completely, and these parameters of the welding is not acceptable. We should go either lower speed or higher heat input. It means that we can modify the parameters. This is what simulation is for. So let's see what other option we have here. In this one we can change the color scheme. We can go for gray or thermal. To me it is the most beautiful one. If you want to select, or you can select the custom, which is the fluid mold or fluid cord. We have something like this, or I would stick to this thermal. And here we can also change the colors if we want, but we leave it as it is. And I'm going to reset everything, and we even can say everything out of range should be turned green, but I'm good. We reset all, and we close this one. Alright, we're going to look at the phase transformation. Here, if we click on phase info and element results, we can see the proportions of every phase. So what is the first phase? The first phase is ferrite. If I said that right, yeah, it is ferrite or ferrite perlite. As the material is ferritic, here we have ferrite here in the base metal, and let's see what happens by passing the time. Here the ferrite of the base metal is not changing, but it affected by the weld here, because it's going to be melted and transferred to another phase. Or we can go to the second phase, which is the fictive phase, or the filler metal. Here we have the filler metal here, and by the end of the process the filler metal should be gone completely. It seems to be done. Yeah, so as we see, very little base metal, filler metal is left in the base metal here and here. So this one is 0.3 is the proportion of the phase remains. So it means that the process parameters was not bad. It's kind of acceptable, but need to be modified in order not to have any filler metal left. The third phase, what is the third phase? It is martensite. So as you see, we have no martensite, but after the welding was done, the friction of the martensite is increasing due to the rapid formation, rapid cooling of the heat from high degree of temperature to the environment. We have martensite formed in the microstructure. Let's go to the next phase, which is phase 4. Phase 4 is bainite. So we see there is no bainite here, but during the process, after formation of the austenite, we're going to we transitioned to bainite and martensite. So the final microstructure is bainitic martensitic structure. Phase 5 must be upper bainite, tempered martensite. So we didn't have any tempered martensite, and no tempered martensite is created. And the last phase is austenite. We see here when we hit the material, austenite forms into the microstructure, and by cooling down it transitioned to bainite and martensite, and we have no remained austenite in the microstructure, which is a really good sign. Yep, it's pretty much everything here. We did the calculation, we did the analysis, thermal analysis and everything else. And now what we can do here, we can save the results. Here we have the temperature node results, and if we want to save the result, we can adjust in this any seconds we want, and right click here, we can save this image, save image as, or we can save image to clipboard. It means we can copy this one, or we can from here we can measure the weld pull, for instance. Here we select one point, and this is another point. We can measure the distance that the material is melted if it's important for us, which is not important in this analysis because we're not measuring any heat affected zone or anything else, but sometimes it might be handy. So I hope you enjoyed. See you in next video.